All right, so have you ever felt like you're just drowning in software jargon? You know all those terms developers use like showstopper or blocker?
Yeah.
Well, today's deep dive is all about kind of cracking the code of software testing lingo.
Oh, nice.
Whether you're prepping for a meeting or brushing up on industry knowledge or just really curious about tech, this is for you.
Yeah, it makes sense.
Because honestly, who hasn't gotten frustrated with a software glitch?
For sure.
Understanding these terms can really help us all navigate the digital landscape a little better.
What's interesting here is that we think of software testing as this like highly technical domain,
Right.
but the core concepts are actually relevant to anyone who uses software.
Yeah.
It's about understanding how quality is ensured, how problems are identified and addressed.
Okay, so let's unpack this, starting with a term that can send chills down any developer's spine.
Oh boy.
The dreaded showstopper.
Ooh, yeah.
I'm guessing it's not as fun as it sounds.
Definitely not.
You know.
I remember once working on a project.
Yeah.
And we discovered a showstopper just days before launch.
Oh, wow.
It was a critical flaw in the user authentication system.
Oh, gee.
Essentially preventing anyone from logging in.
Oh, no.
We had to work around the clock to fix it.
Oh, my gosh.
It was a stressful experience.
Yeah.
But it highlighted how crucial it is to catch these issues early on.
Wow, that sounds intense.
Yeah.
So a showstopper isn't just a minor hiccup.
Right.
It's a major roadblock that brings everything to a screeching halt. And it's not just about halting development.
Yeah.
It's about the impact on users' revenue and even reputation.
Exactly.
Yeah.
Formally, a showstopper is defined as a critical defect that prevents the software from functioning as intended or from being tested further. It demands immediate attention and usually involves the most senior developers on the project.
So it's like hitting a brick wall.
Right.
New detours, no workarounds.
Yep.
You're stuck until that obstacle is removed. Thankfully, not every problem is a showstopper. Right.
We've got other categories of software hiccups.
Absolutely.
Okay, good.
Broadly speaking, we have issues, which are any problems or glitches that arise during development. These can range in severity, from minor inconveniences to more significant concerns.
Okay.
Think of it like this.
Yeah.
You might have a leaky faucet in your kitchen.
Okay.
It's annoying.
Right.
Needs fixing.
Yeah.
But you can still live in the house, right?
Yeah, it's a good way to put it.
Yeah.
So an issue doesn't necessarily bring everything to a standstill.
Right.
Then within the realm of issues, we have those pesky little creatures called bugs.
Oh, yeah.
Tell me, is it true that developers actually leave crumbs in the code to attract these bugs? I had to ask.
Well, I wish it were that simple.
Okay.
But no bugs aren't literal insects.
Okay.
In software, a bug is a specific fault in the code that causes the program to behave unexpectedly or produce incorrect results. They're often identified during testing.
And sometimes they stem from simple coding errors like a missing semicolon or a typo.
Oh, yeah.
Other times they can be much more complex
Yeah.
and difficult to track down.
So a bug is like a loose screw in a machine.
Yeah.
It might still work for a while, but that loose screw needs tightening to prevent bigger issues down the line.
Exactly.
But what about when an issue prevents you from even working on the software?
Oh.
Is that where blockers come in?
You got it. A blocker is an issue that prevents testers or developers from proceeding with their work.
Got you.
Imagine you're working on a feature and suddenly you hit a wall. You can't test or develop further because a specific part of the software just won't cooperate.
Right.
That's a blocker.
That's happened to me countless times.
Oh, yeah.
I get that frustrated feeling like, come on, why isn't this working?
Yeah, definitely.
So a blocker is like a train delay on one specific route. It doesn't shut down the entire train system, but it stops anyone on that route from getting where they need to go.
Right.
And just like showstoppers, blockers need to be resolved quickly.
Yeah.
Because it can impact project timelines.
For sure.
Now, while blockers are about roadblocks to progress, it's also crucial to understand the scale of issues.
Yeah.
Which brings us to the distinction between critical and minor issues.
Okay.
Right? Because not all issues are created equal.
Right.
Some are just minor annoyances, while others have the potential to bring the whole system down. So where do we draw the line between a critical issue and a minor one?
A critical issue is a serious problem affecting essential parts of the application.
Okay.
It demands quick resolution because of its impact on the user experience.
Yeah.
But unlike a showstopper, it doesn't completely halt all functionality.
Gotcha.
Take, for example, a banking app where the fund transfer function malfunctions.
Okay.
It's a major inconvenience, but Other functions, like checking your balance or viewing statements, might still work.
So it's like driving a car in the summer with a broken AC. You can technically still drive, but the experience is far from ideal.
Exactly.
So if a critical issue is like a broken AC, what's a minor issue? Is it like a scratch on the paint job?
Pretty much.
Okay.
A minor issue is a non-critical problem that doesn't significantly affect the application's core functions or overall user experience.
Okay.
Think of it as an aesthetic glitch, like an app's user profile page displaying an email address without proper formatting.
Okay.
It's visually annoying, but it doesn't prevent the app from working as intended.
So a minor issue is like that squeaky door in your house. It's noticeable, maybe even a little irritating.
Yeah.
But it doesn't disrupt the house's fundamental purpose.
Right.
But there's another pair of terms that often trip people up.
Oh, yeah.
Priority and severity. I'll admit I've mixed them up before.
It happens.
Can you help us untangle this one?
Absolutely.
All right.
Priority and severity are distinct concepts that are crucial in software development. Priority refers to how quickly an issue needs to be resolved.
Based on its business impact.
Gotcha.
High priority issues demand immediate attention to keep things running smoothly.
Right.
Or to meet deadlines. Severity, on the other hand, defines the extent of an issue's impact on the application itself.
Okay.
High severity issues usually involve core functionality or security vulnerabilities, making them a major concern.
Okay, so let's say we have an e-commerce site.
Okay.
A broken search function would be a high priority issue as it directly impacts user experience and sales.
Right.
But it might have moderate severity because users can still browse products through categories.
Yeah.
However, a bug that causes data loss during transactions.
Oh.
That's a whole different ball game.
Yeah.
That would be both high severity and high priority, right?
Exactly.
A major problem that needs immediate attention.
Yes.
Okay.
It's the QA team that usually determines both the priority and severity of issues, often in collaboration with product managers.
Gotcha.
This helps guide developers in prioritizing their workload.
And addressing issues based on their potential impact.
So it's like assessing a storm.
Okay.
Severity is the storm's intensity, how much damage it can cause.
Right.
Priority is how urgently you need to prepare based on that severity and the likelihood of hitting your area.
For sure.
But even with all this testing and attention to detail, sometimes unexpected problems pop up. What about those sneaky regression issues that seem to come out of nowhere?
Ah, yes, regression issues. Yeah. These are the ones that make you wonder, didn't we already fix that? A regression issue occurs when a previously working feature stops functioning correctly after new code changes or updates are implemented.
Gotcha.
Essentially, it means that a new development or fix has inadvertently affected existing functionality.
Ugh. It's like fixing a leak in your bathroom, only to discover a new leak sprung up in your kitchen because of the plumbing work.
Yeah.
So frustrating.
Yeah.
So regression issues are essentially unintended consequences. They highlight the delicate balance of software development, where even the smallest change can ripple outwards.
Absolutely.
And they're a big deal because they indicate that something in the recent changes has negatively impacted something that was already working properly. They need to be addressed promptly to ensure smooth functionality across both new and existing features.
Right.
But let's talk about situations that require immediate action.
Okay.
Emergency repair mode.
Yeah.
That's where hotfixes come into play.
All right.
Okay, so a hotfix is like a software equivalent of a Band-Aid, a quick fix to stop the bleeding.
That's a good analogy.
Right.
A hotfix is a quick, targeted fix deployed to resolve a critical issue that's causing problems in a live environment.
Gotcha.
It's a way to address a problem immediately without waiting for the next scheduled release or update.
Okay.
For example, if the login function on a popular website suddenly stops working and users can't access their accounts, a hotfix would be deployed swiftly to restore access and minimize disruption.
So it's like patching a flat tire in the middle of a road trip.
Yeah.
It's a temporary fix, but it's essential to keep moving forward and reach your destination.
Exactly.
But what about those more routine updates that fix minor issues and improve overall performance?
Yeah.
Those are patches, right?
That's right.
Okay.
A patch is a collection of updates and bug fixes applied to software to improve functionality, security, or address minor issues.
Okay.
Think of your monthly mobile app update. It might fix some minor bugs, add new features, and enhance security.
Right.
That would be considered a patch.
So it's like taking your car in for a regular tune-up. You're not fixing a major breakdown, but you're addressing various areas to ensure optimal performance and prevent potential issues down the road.
Exactly.
We've covered a lot of ground here.
Yeah.
From showstoppers to patches.
We have.
It's fascinating to see how much goes into ensuring the software we use every day is functional and reliable.
Absolutely.
Yeah.
But we've only just scratched the surface.
Oh, really?
There's a whole other layer to explore, which involves understanding how software is tested at different stages of its development.
All right, now that we've laid the groundwork, I'm ready to delve deeper into the world of software testing levels.
Great. Think of it like building a house.
Okay.
You wouldn't just start slapping on bricks and hope for the best.
Right.
You'd want to make sure each individual component is sound.
Right.
Then check how they fit together. And finally evaluate the overall structure.
Ah, so that's where these different levels of testing come in.
Exactly.
It's about examining the software at different stages of complexity.
Yes. We start with the most fundamental level.
Okay.
Unit testing.
Unit testing.
This is where individual units of code, like functions or modules, are tested in isolation.
Okay.
It's like inspecting each brick to make sure it's strong and free from cracks.
So if we're sticking with the house analogy, unit testing would be like making sure each brick is perfect before we even think about building a wall.
Precisely. And this is typically done by developers themselves as they write the code.
Okay.
It helps catch those pesky bugs early on before they snowball into bigger problems later in the development process.
That makes sense. Catch those little gremlins before they multiply.
Exactly.
But once you've tested all the individual bricks, how do you ensure they fit together seamlessly?
Right.
I'm guessing that's where integration testing comes in.
You got it.
Okay.
Integration testing is the next level up, where we check if the different units of code, those functions and modules we tested individually, actually play nicely together.
Okay.
It's like making sure the bricks fit together properly to form a sturdy wall.
Ah, so it's not enough to have perfect individual bricks.
Right.
You need to make sure they connect and interact correctly to create a solid foundation.
Exactly. Integration testing is all about finding those interface bugs.
Okay.
The issues that arise when different parts of the software try to communicate with each other.
I can see why that's important. You could have perfectly working individual components.
Yeah.
But if they don't connect properly, the whole system falls apart. But we're still talking about walls at this point, right?
Yeah.
What about testing the entire house?
That's where system testing comes into the picture.
Okay.
It's the level where we test the complete integrated system as a whole.
Right.
We're no longer looking at individual bricks or walls.
Right.
We're evaluating the entire house from foundation to roof.
So system testing is like taking the software for a test drive.
Precisely.
We're making sure all the parts work together harmoniously.
Yeah.
And that the overall functionality meets expectations.
We're checking if the software meets the specified requirements.
Okay.
Functions as expected in different environments and handles various user scenarios.
Right.
It's a comprehensive evaluation of the software's overall functionality and performance.
Okay, so we've tested the individual parts.
Right.
We've made sure they integrate properly.
Yep.
And we've evaluated the entire system. What's next?
Oh.
Do we hand over the keys to the homeowner?
Not quite yet. There's one more crucial level to conquer before we unleash the software upon the world.
All right.
Acceptance testing.
Acceptance testing.
This is where we ensure the software meets the needs and expectations of the end users.
So it's like the final walkthrough with the homeowner. We're making sure they're happy with the layout. That finishes the overall feel of the house.
In acceptance testing, the focus shifts from technical correctness to user satisfaction.
Gotcha.
We involve actual users or representatives of the target audience to evaluate the software's usability, look and feel, and overall experience.
Yeah.
It's about getting that final seal of approval from the people who will actually be using the software.
This all makes perfect sense.
Good.
Each level of testing builds upon the previous one, ensuring the software is solid, functional, and ultimately delivers a positive user experience.
Yeah.
But I'm curious, are there any other types of testing beyond these core levels?
There are actually several other types of testing that focus on specific aspects of software quality and performance.
Right.
One important type is performance testing.
Performance testing.
Which, as the name suggests, evaluates how well this software performs under different conditions.
So it's like stress testing the house.
Yeah.
Seeing how it holds up in a hurricane or an earthquake.
That's a great analogy. Performance testing helps identify bottlenecks, assess response times, and ensure the software can handle the expected user load without crashing or slowing down.
That sounds crucial, especially for applications that need to handle a large number of users simultaneously.
Right.
Like online games or e-commerce platforms. What about security?
Yeah.
Is there a specific type of testing for that?
Absolutely. Security testing.
Security testing.
Focuses on identifying vulnerabilities that could be exploited by malicious actors.
Okay.
It's like checking the locks on all the doors and windows, making sure the house is secure.
So security testing involves techniques like trying to break into the software to identify weaknesses.
Precisely. Security testing often involves penetration testing, where ethical hackers try to find weaknesses in the software's defenses.
Gotcha.
There's also vulnerability scanning, which uses automated tools to identify potential security risks.
I can see why security testing is paramount in today's digital landscape. With so much sensitive data being stored and transmitted, online security is a top priority.
For sure.
Now, we've talked about performance and security, but what about the user experience?
Right.
Is there a specific type of testing that focuses on that?
Yes, there is. It's called usability testing.
Usability testing.
And it focuses on how easy and enjoyable the software is to use. Think of it as inviting friends over to your new house and observing how they navigate the space. Do they find everything easily?
Right.
Are there any areas that are confusing or frustrating?
So usability testing involves observing real users as they interact with the software and gathering feedback on their experience.
Exactly. It's about identifying any areas that are confusing, frustrating, or difficult to use.
Okay.
Based on this feedback, developers can make adjustments to improve the software's design and make it more intuitive and user-friendly.
This all highlights the importance of having diverse perspectives involved in the testing process.
Absolutely.
You need developers who understand the technical intricacies, security experts who can identify vulnerabilities,
Right.
and real users who can provide feedback on the overall experience.
The best software is created through collaboration and a shared commitment to quality. It's about bringing together different perspectives and expertise to ensure the software meets the highest standards.
Well, I have to say, this deep dive into software testing has been incredibly enlightening.
Oh, good.
I had no idea there were so many different levels and types of testing involved.
Yep.
It's amazing to see the level of detail and rigor that goes into ensuring the software we use every day is functional, reliable, and user-friendly.
It all comes down to delivering a high-quality product that meets user needs and expectations.
Yeah.
After all, what good is a house if it's not structurally sound secure and enjoyable to live in?
Exactly. So now that we've explored the intricate world of software testing levels, I have one final question for you.
Okay.
And it involves putting all this knowledge into practice.
All right.
Ready for a challenge?
I think so.
Okay, so let's put all this newfound knowledge to the test.
Right.
Think about the software you use every day.
Yeah.
Pick one that really stands out.
Okay.
Now consider which testing levels we talked about. Unit integration, system acceptance.
Right.
Which ones do you think were absolutely crucial for that specific application?
It's a fun exercise because it makes you think about the software from the creator's point of view.
Right. Like if it's a banking app.
Yeah.
Security testing would have been paramount.
Oh, for sure.
You wouldn't want any vulnerabilities putting your financial data at risk.
Exactly. But for a social media app, usability testing might take center stage.
Right.
It needs to be intuitive and engaging to keep users scrolling.
And let's not forget performance testing for something like a video streaming service.
Oh, yeah.
Buffering is the ultimate buzzkill.
Absolutely. It really highlights how different software applications have different priorities.
Yeah.
And how those priorities shape the testing process.
This whole deep dive has been a real eye-opener.
Good.
I used to think of software testing as this behind-the-scenes technical process.
Yeah.
But now I see it's about so much more.
Right.
It's about ensuring quality, reliability, and ultimately creating a positive user experience.
And it's a continuous journey. Software is constantly evolving with new features and updates being released all the time.
Right.
So the testing never really stops.
That makes sense. It's like a never-ending cycle of building, testing, refining, and improving. And it makes me appreciate all the hard work and dedication that goes into creating the software we rely on every day.
Absolutely. So the next time you encounter a software glitch, don't just curse the developers.
Right.
Remember all the steps involved in getting that software to you.
Yeah.
And when you have a seamless, enjoyable experience, take a moment to appreciate the thorough testing that made it possible.
Well said.
Thanks.
We've decoded the jargon, explored the testing levels, and gained a newfound respect for the art of software testing.
Yeah!
I think it's safe to say we've officially leveled up our tech knowledge.
I think so, too. And remember, the learning doesn't stop here.
Right.
The world of technology is constantly evolving, so stay curious, keep exploring, and never be afraid to ask questions.
That's the perfect note to end on.
Right.
Until our next deep dive, keep those curiosity engines running.
Yeah. And as always, feel free to share your thoughts, questions, and software adventures with us on social media.
Who knows? Your insights might just inspire our next exploration into the fascinating world of tech.
Absolutely.